ACM SIGSOFT webinar. This webcast is part of ACM SIGSOFT's commitment to provide value to its current and future members. The webinar series features speakers from all around software engineering. Some of them come to conferences like ICSE and AAC and FSE or other conferences in the space. And other times we pick people who are distinguished paper authors or keynote speakers at different conferences to come and talk to us. In terms of how this is going to work, the speaker, Chanchal Roy, will come in and talk for about 40 minutes, and then following that, there'll be time for Q&A. At the bottom of your Zoom should have a Q&A button. If you open it up, you should be able to ask questions on that thing, and then at the end, when we do the Q&A session, we'll pick out some good questions and ask Chanchal those questions verbally so we can hear them. And secondly, if anybody needs a certificate of attendance, please say so in the chat. And Sridhar Chamalakanda and I, who are both the moderators, will look at those later and create those for you and send them out by email. It looks like Professor Roy has joined us. I want to say welcome to Chanchal Roy, and let me introduce you, Chanchal, before you get started. So Chanchal is the director of the Industry Stream Multi-University NSERC CREATE Graduate Program on Software Analytics Research and Software Research Lab, and a professor of software engineering and computer science at the University of Saskatchewan in Saskatchewan, Canada, which I guess is in Saskatoon. Dr. Roy works in the broad area of software engineering with particular emphasis on software clone detection and management, software evolution and maintenance, recommender systems in software engineering, automated software debugging, and big data analytics in software engineering, which is kind of the popular places in software engineering. His contributions to the software maintenance community, and particularly to the software clones community, have been highly influential, winning him 4 10-year most influential paper awards at international conferences. And recently, he was awarded with the Clones Lifetime Achievement Award and became the second person ever to have received this award. He has been recognized with a New Scientist Research Award at the College of Arts and Sciences in University of Saskatoon, the University-wide New Researcher Award, the GSA Advising Excellence Award, and the Outstanding Young Computer Science Researcher Award by Canada's Computing Research Community. He has attracted over $6 million in external funding since joining University of Saskatchewan, has given invited keynote talks at lots of conferences, and has served often as organizing chair and in program committees of international conferences, including ICPC in 2014 with me. So I would like to say welcome to Professor Roy, who's going to be talking to us about building global software engineering pipelines, lessons from Bangladeshi graduate talent and LLM-driven research. So why don't I let you take it away, Dr. Roy.
Okay, thank you, Dr. Andy Bagel, and also Dr. Sridhar. It's a really real pleasure to get invited to this ACM SIGSOFT webinar. And I really thank you and honored to be invited. And and thanks also for the nice introduction. And for all the participants, thank you for joining. And as you saw from the title, this talk is more on talking about Bangladeshi talent and to see how they have been doing, what they have been doing, and what we could do further with both global different universities, in particular with US and Canadian universities, and what Bangladeshi talents could do further. So first of all, I want to introduce our lab. We have 2 labs backstage. So now this is our lab. We have 2 labs. We worked closely together. One is directed by Dr. Banani Roy, and another is myself and Dr. Kevin Schneider. They are the people, if you want to see their face. And then one of the things that in our lab is that we hire a lot of students from Bangladesh. Kind of over 75% of our graduate students are from Bangladesh. And this talk is mostly focused on Bangladeshi students. And if you look at in this slide, is our research areas over the time, mostly a lot on clones. So I want to see what is clone first. So as you see from this picture, we want to see what is clone. Clones are 2 pairs, 2 fragments of code that are, similar to each other with some definition of similarity. So you don't know what is that definition, but, we will see. And some of the students have been working on clones here, different students from different universities, KUET, Brac, and different other universities. So what is clone? So there are two types of like clones, mostly exact and near miss. But I will say okay, type 1, type 2, and type 3, type 4. So you can exactly copy. That's very simple. I will start with a very simple example. And as I was saying, this is a kind of research highlight and talents. So I will not go in depth for any of those things. But for type 1 or exact clones, you just copy paste right in the IDE and then you use in different context. Or sometimes you can rename them, or you can change the variable names or whatever. And sometimes you really do a lot of changes after you copy from any places or like a Stack Overflow, and then you make a lot of changes and you can reuse it in different places. Or there could be even semantic clones or type 4 clones where there is no similarity between the text. And it could be reordering of the lines, or even changing the loops, or even sometimes like for loop to while loop, or sometimes maybe recursion. So there is no similarity between the text. And then finally, there is even cross-language clones where you have, let's say, simple function like checking the palindrome look different. Even for within Python, this is this, and this. And if you have a problem to find out what are the similar palindrome functions in the source code, then how can you find out what technologies can you use? What are the algorithms that could be used? And so those are the things we have worked, and quite a lot over the time. And the question is, why does this matter? And the answer is yes, it does matter, because sometimes there could be even 50% clones in a software systems. And then somebody might say, okay, so what, right? And I have a lot of reasons for those clones to be there, because I always do it. We always copy paste, we reuse, we don't have enough time. So we copy paste, we have language restrictions. And while you do it, the question is, you are maybe making a big mistake, because when you do the copy paste, you might be ended up introducing bugs. You might copy a fragment that has already bug, and then you are adapting it, so you are propagating the bug. Or you are doing the change, but you are not doing it consistently, because editing is always a problem. And sometimes it says that it could lead to severe unexpected behavior, and it's a number one bad smells, could cost in millions, like including accidents in self-driving cars, or even there are some other more statistics. On the other hand, as I was saying, cloning is intentional. It's a principal re-engineering tool. People intentionally clone because of a lot of benefits, right? And they may not be always harmful. There are a lot of good things. So there are good shift and bad shift. And that's why what we do clone management. Cloning, so you let people do clone, and then you manage them so that you can avoid the risks and you can gain the benefits. There are a lot of different clone detection tools available, including commercial ones. There are also different tools for large scale clone detection, because they are important for different kinds of things like license violations. And we also did different kinds of large scale clone detection that can handle millions of lines of code in standard hardware. And also we did cross-language clone detection, like I was showing you that code fragments in different programming languages, where you can, still you can able to find them. And what we do not even compare the code. We compare maybe their sequence of method calls or the library description and different ways. And with recently, what we did with clone detection cross-language one, like using transcoder. So if you have different systems of different programming languages, then you can convert them to the same programming language. Then you can use any tool that can work on that language, and you can detect clone. And then recently we have been using LLMs. So like we are using LLMs for translation and then converting to the same language, and exploring also translation for other purposes, because you need a lot of those translation from legacy system to modern systems. So by using those translation, we also exploring what kind of translation work better. So if you give directly source code, does it work better? Or if you have algorithm-based translation that works better. So we found that algorithm is better. And then we have the problem with those tools. We have lack of evaluation, because precision recall is always a factor. And if you look at this, for those different kinds of tools, right? So what is recall, right? I think most of you know. Recall is like, if you want to say that your tool is good in terms of recall, then you need to know what are those different clones available in that system, and getting that, making sure that how many clones are there is very difficult. And benchmarking is further difficult, because manual validation is not correct. Judges might disagree. Or if you just compare function clones for a small system that has maybe 500 pairs, it will be n into n minus 1 by 2. So it's a kind of n squared problem. And if clones even appear like 2 lines, 3 lines, 5 lines, so you don't know how many combinations could be. And that's why we did kind of a lot of work in building benchmark, building clone detection tools. And then all of our tools in the past, we had these problems, like we had a smaller benchmark, or we have benchmark only for one system, or we have big clone bench that was only, so it has millions of code or millions of clone pairs. We did it with a lot of validation. We have CLC CDA data set, but these are all like a smaller data set or supports few languages. So what we did with LLM, we use LLM prompting. When LLM actually came at the beginning, we started using LLM and using just simple prompts, and then we generated this benchmark that can support more languages, and you can make it mostly automated. But you also still need to do a lot of manual validation and a lot of testing. So what we did, we not only make use of LLM, but then we made sure with different kinds of validation, including automated tools that can really validate those real one. Then we use functional testing, and then we use also another machine learning tool that we develop. And furthermore, we also make use of 9 validators to build that benchmark. That's a GPT clone bench. And then we also explored further how good LLM is in generating clones, like code completion or clone completion. We found good accuracy, although if you need to really play with the context, so it's not that good if you cannot really provide right context. And then you have to make sure that those clones are kind of reflecting a human kind of writing. So that's another thing. So we also looked at the Blue score. And I will yeah, so we need good examples, but generating is sometimes not always easy. Translation might work properly, but we need to do further study. And we also looked at then, okay, if we have these classical clone detectors, and this is a new era, like large language based clone detection era, right? So whether the tools that the people develop over the decades are good enough. So we also look at different kinds of tools, and when we compare with recent tools, because when you have this recent tools, or when you have this code generated by GPT, they are kind of different. And we often there might be different or different kind of style. So we also studying that part. But then what we looked at, we wanted to make use of this classical detectors, that the clone detectors that are already out there, instead of those GPT-based clone detectors. So we explored it, and we saw that like even our simple tool that we develop in our lab, CloneWorks, with a lot of normalizations, a lot of processing, when you can translate code, you can kind of closely do to the GPT bench or those large language-based clone detectors. And in the same time, you can get it robust and get all those benefits of a classical detector. And yes, so you can still do it. You can make use of it. They are not obsolete, but maybe we need to play with them. We have also students working on software bug. And then they are from different universities as well, including Khulna University and Joshua University and other places. So what we did in bugs, we did a lot of work. One of my students, Masood Rahman, he is now a faculty at Dalhousie University and a lot of award-winning students. He did a lot of work on bugs, but recently some of these students are doing like fine-tuning, because we're talking about LLMs, fine-tuning the models and see whether context or project-specific context could really improve the bug detection or bug localization. We also have this IDE-based one. And then we have, we did a lot of bugs from the bug reports, bug localization. But what we are doing recently, like Mukta is doing, she actually defended yesterday her PhD, congrats to her. She is doing like multimedia bugs. So bug report might not only have the text, but it might have multimedia, it might have video. And she has been exploring LLM in doing all those different kinds of bug reports and bug localization. We are also looking at using LLM for issue resolution. So what is issue resolution? Like if you have some issues, right, and then you fix it, you need to fix it, right? So we are exploring whether LLM could help. And we noticed that the LLM is indeed helpful. Developers have been using LLM for different kinds of getting at least some idea and putting into context and getting some help to resolve the issue. But we also noticed that maybe it is not yet out there to fully resolve the problems of issue resolution. We still need context. Some of our students, like Shomo, has been working on like explainable AI, because anything you do, we need to explain it, right? We have been doing different ways to explain the AI, like aggregation. We have different kinds of tools for explainability. and then you can aggregate them and you can get the good result. Or maybe you can use contextual. Again, context is very important. Contextual and contrast step, both. So you look at the similarity and you look at the dissimilarity, and you can weight at the score, and you can have a better explanation what is happening inside. A lot of time we do not know what is happening with our machine learning model. So this kind of gives us some insights. I will let the future work remain to discuss later. Shamimur Rahman from KUET is also doing a lot of work similar to this, like how to resolve bugs or doing the code review. And he's dealing with code review is a kind of very important problem. A lot of people at Microsoft, all companies, they do it. But there might be communication gap. There might be, some people might not understand what you're looking for. So you write a piece of code and then you say, please kind of fix it, and they don't understand. They come back. So communication gap, there might be, sometimes you use, nesty language, like civil and uncivil comments. So Shamim has been working a lot with quite a lot of different publications, including FSC, on resolving those problems. How can we really make comments from, and how can we use LLMs for make those code review comments from uncivil to civil, or improve the communication, all those different other things. We have also students, those are not only that all those bugs and other things, they are going further. They are also, everybody knows, right? Stack Overflow. I don't think anyone here, they do not know Stack Overflow. And Stack Overflow has millions of questions, like 24 millions. But the problem is, not all the questions are being resolved. 51% of them are unresolved. A lot of those questions do not have code fragments in it. And if you don't have code fragment, then how do you answer people? Or how do you get the help? They are just saying it. So if somebody has a question, it's, or somebody says, oh, I got this bug while I was running this code. But then when you try to reproduce that bug, can I really get the same bug so that I can try and fix it and I will help them? Then you cannot, resolve, you cannot really run it. Like you cannot reproduce the bug that the question poster was saying. So we are, like Shoykot has been exploring a lot of these things, including, recommending code fragment. If there is a Stack Overflow question, we have been using LLM on some other technologies to recommend questions for that code fragment. So we are improving that Stack Overflow questions. We are looking at the challenges of reproducibility. We are suggesting how to reproduce that code fragments. And we have prediction models. So what questions need really reproducibility? And we have this solution, right? So, and it can automatically, it will give you the gen snippet would automatically give you the code fragment that you need for the question that is missing the code fragment. So improving and supporting the developer community. And of course, LLM is not that good, and I will talk about it maybe later. But then we have also another student, Suborno, from CUET, has been working on, he's actually defending today, this afternoon. He's has worked a lot on improving those questions further. Like if you have, Stack Overflow questions and code fragment, can we really, improve them with some automated comments so that, people can understand what is this problem, what is this code fragment about, and people can, easily understand, or they could respond properly. And then some of the students have been working on reproducibility. And reproducibility, recently we actually explored reproducibility of a lot of papers, in particular one of the top conferences in the area. And then we looked at that. Okay, while people share the data, while people share the replication package, there are issues with reproducibility because, a lot of them cannot be reproduce. So data is available, but you cannot reproduce. So there are some ways we did it, but I'm not going to introduce in them. And we see that they are highly available, but their executability low, but then they are rarely reproducible. So you share your data as a part of a paper, but people cannot replicate it. So we studied that, and we provide a lot of suggestions. And then towards the same goal, we also, and actually we have been working over the last 7-8 years on workflows. So how can you automate? Like it's not only that one software you reproduce, but also you can have a complete workflow. So if you have a pipeline of set of tools to be used for doing a certain task, we are now completely automated without going into dirty details. And it is just by drag and drop. So several of our students have been working on it. And then like here, Mainul Hossain, who actually recently graduated, has been working on it quite heavily with Dr. Bonani Roy and us. We have a tool available too. This is kind of a workflow system. People can just compute some scientific workflows or large complex workflows just by drag and drop elements. and you can explore it here. And then what some of the students in the lab are doing, they are exploring LLMs to further improve it, like in terms of writing those workflows or in terms of finding out what are the issues the developers could face, all those different things we have been exploring. And then not only that, actually in our lab, we're also exploring, like Cynthia from this IC lab, we're also exploring when you work together, a lot of people work together, then what happens? So when you work together and if you do not deal with them properly, if there's diversity or communication gap, there could be a lot of community smells. Like smells means like same as I was talking about this code review issue. So this is kind of a broader view of code review where you get a lot of smells, in particular if you work with diverse set of people, and that could introduce technical depth. And technical depth means you are introducing some problems that will create problem in the future, or maybe right now you are not understanding what is going on. And then she's further working on looking at the gender diversity. What happens? What happens if you male and female developers are there? And it was found that, okay, if you have female developers, maybe they are writing better code, they have fewer security hotspots, and you have, and they have maybe better coding standards. And so that's an interesting study. And we actually hire a lot of female students, and that's a good news for my lab as well. And right now, actually, we have a lot, like 40%, 30% female students. Yes, I will skip this future, but everybody knows the AI issues with AI, the context issue, hallucination issue, the stability issue, security issue, right? So, but then I will talk about this particular another work a little bit more, that because we have been using LLM and because LLM is always out there and there are a lot of things coming up with LLM everywhere, we need to think about the sustainability of LLM. Like what happens? I mean, if you cannot really train a model, what happens? It takes millions of dollars. Like everybody is using LLM-based things. Like even developers, 85% of developers feel confident. While when they use LLM, they are good in writing their code. But then when you train a model, just training just GPT-3 could cost $4 million because there are a lot of price for those GPUs. And there are also hidden costs. Like even Amazon reported, they have 90% of the cost is by just inference. Right, every day that it's Meta is kind of dealing with 200 trillion inference per day. So and all those things actually emitting, not only that it is taking resources, it is taking money, but they're also reducing a lot of carbon, right? So carbon emissions. So that's why we're trying to develop models that can be lightweight, so reduce the LLMs. And we have a model that is actually doing it, and we are doing it in terms of context. So we have this teacher LLM, teacher model, and then we try to have a student model that is, that takes less size and that is, more efficient, not more efficient, but it will have kind of similar performance, but it will do better because we are doing context sensitive, neural kind of pruning, neural architecture, source pruning, and along with those other different kinds of quantization or knowledge distillation approaches. And we found kind of quite a good result because our model is kind of 1.6 megabyte compared to, let's say, CodeBart, which is 481. And then we also looked at, different context. What happens? Because it is context-based, as I said, the pruning is context-based. We have to prune, right, the number of, let's say, attention heads. So, and then we see that it is doing really good job for different kinds of software engineering tasks. And you can see for the inference, like our tool is kind of inference is like 6.95 compared to like memory engine, like memory uses. And carbon, if we consider our one is 0, and then they are kind of, this is the percentage you can see. So other models showing a lot of carbon uses, carbon emission. And we have also, because we have been using AI all the time, we also have been exploring with one of my colleagues, Debajyoti Mondal, Dr. Debajyoti Mondal, and with Priyata, who is a Brac alumni, about AI policy. Is AI really good? Should I be careful? What are the risks? What are the pros and cons? What are the things we have to do? So we have been, studying all those things and even doing larger scale developer studies to find all those different kinds of things. Okay, so vision is again, AI is important. AI is doing a lot of things, but we are not yet there. AI could be screwing up. And I don't think anyone, you are here in this webinar, how many of you will be confident to to fly in an airplane that was developed with AI. Because the recent Gora report from like Google, they're saying, okay, there are a lot of people have been using it, a lot of things are going on, but then people are not really sure about it themselves. If those people are doing it, even they are not sure what to do. Like, okay, there are other students in the lab, they are doing different kinds of other research, including adversarial attack or like release node generation, testing, backporting, software maintenance, like a lot of different software evolution, reinforcement learning, and kind of highlights of our lab that students what have been doing so far. And this is kind of targeted to our potential students, kind of to see what we have been doing and what is software engineering is, because a lot of our universities in Bangladesh, we have kind of little bit less idea about software engineering. We do a lot of machine learning, a lot of image processing, but as you now see, software engineering is solving a lot of kind of pressing problems, and that industry needs. So if you, and like in this LLMs era, like if you do not know all those different problems, and if you do not know how to deal with LLM, the probability of getting, running or entering into a job market is also kind of, getting kind of, a little bit tough. And our students, yes, they are working in these different areas, including our alumni that, like I was saying, I have supervised or co-supervised about 114, including I am a director of a multi-university CUET program that has a lot of different kinds of funding in the millions. Under that, I also have a lot of other students, but I'm not their direct supervisor. But these students have been doing really good. They are getting a lot of different awards, ICM ACCC award, even Masood Rahman, as I was talking about, he worked on bugs. Right now, a faculty at Dalhousie, he's working on governor. He also got Governor General's Gold Medal Award. And yes, some of the faculty, I was talking about this, Masood Rahman, some of this, like I have a lot of alumni, we have a lot of students graduated, but some of these students are in different good companies. Those are all Bangladeshi students, just to let you know. And there's a faculty, one of my students, Fahim Gibran, he's from IUT, and he even became a professor, actually. So what do we do, how we do, and how did we get kind of quite successful in our work? We have a kind of a pipeline where we try to hire strong students by making use of a support network. And then we have, it's kind of a back and forth loop. And we have a lab that is like a family. And based on that, we produce excellence research. So this is our core. So what is my principle? What I do? This is not really my principle. This is kind of automatically comes to me. So these students are not my lab members. They are our family, and they are building care, empowerment, and excellence. So what is family means in academic context? So if you have a family member, you can assign responsibility. You are making sure that you will take their care. You have trust, belonging, you have shared journey, right? So this belonging is the core principle in our lab. The belonging is the foundation, and we follow on building, a family. So what is family? I mean, I'm not invading their personal space, right? But I'm supporting them in different ways, right? You make the boundaries, but you empower them, and that's the principle. So our mentorship is, yes, of oil, or if you have a care for the students, and if they know it, if they believe in you, then care will enable trust. Trust will enable empowerment. And when you are empowered, research will automatically come. Excellence will follow, right? And we, of course, by doing this, we have different strategies to supporting the students. We're flexible. We support them in different ways, including top-ups, financial supports. We are very serious whether somebody is in trouble, including in academics, what is going on, if somebody is weak, or if they need some help from a senior, different blah, blah, blah. And what we do more also is to being active culturally, because we think that socially, we need to build social communication, because social communication is the key. Even we actually we arranged and celebrated marriage, let's say for recently, last year actually, just for Oditi Dhali and Biraj Shah. And we arranged without their parents. The lab members become the bride and bridegroom's family, and we had celebrated it. So that's our lab culture. And of course, when we do the culture, that comes the excellence, because culture automatically builds the collaboration. And that's what the beauty in our lab. And that produces high quality research. And again, I try to ride the boat. I guide the boat, but my students, they choose the destination, how to go, where to go, right? I help them. Of course, I make them accountable. And respect and trust, very important. And in doing that, in this principle, I make the students expert in the room. So I make sure that they become the expert. I just facilitate them. We also emphasize growth over prestige. We always do not focus, oh, you only have to publish in XC or in this top conference. Sometimes we publish in a little bit lower tier venues as well, because we know that that particular student is possibly weak, right? So we make them confident. So prestige is earned, confidence is built. We try to build their confidence. Of course, we do a lot of empowerment things. We do honest conversation. We force. We maybe because we are family, right? We let them, running supervised juniors. We ask. We encourage them to take risks, because empowerment is the vaccine against failure. See, so that our students do not fail. Nobody in our lab fail until now. With my long history of supervision, with so many, actually nobody left our lab. Nobody failed. Kind of somebody had family issues. That's a different thing. But we tried. This is a pride. Even a lot of students came to our lab, but this is our pride that we try to empower everyone. This is our sorry. Confidence is not inherited. It is engineered. We try to engineer confidence in our lab. And of course, a lot of you may be looking for, okay, how do I recruit, right? So as I was saying, we have a kind of a strong support network beyond Bangladesh and beyond. Former institutions, I came from Bangladesh. My students' networks, former colleagues, known mentors. And because it works, because we have reliable information, we have long-term understanding, we know their culture, we have a strong community fit, we know that they will, they will be well fitted. So what I do, I don't, sometimes I read the recommendation letter, but not just the recommendation. What I look for more, what happens with that particular student, we look for their consistency, resilience, how they reply, the integrity, whether it is generic, if somebody is exaggerating their facts. And then I make use of this support network to really cross-check them. And we have a lot of different support networks from different institutions, as you see from here. A lot of helping hand from, we make use of them. A lot of people from, a lot of professors from Khulna University, some of them like here, Amit Mondol and Dr. Manishankar Mondol are also my former PhD students. Dr. Rafizul Islam also did PhD from here. But then these guys, they're helping us. And Dr. Anisur Rahman is kind of right now at also, a vice chancellor for Khan Bahadur National University. So we make use of the support network, including our previous students. And then we have this Mainul Hossain, who is helping us not only this building scientific workflow, but also a big resource of support network. Dr. Ashish Mondal, he did postdoc with us and then work quantum computing, quantum bugs in our lab as well with Mr. Dr. Nadim, who was also a PhD student in our lab. So we have a lot of different support network, including different other universities, Dr. Shahnaz Ripon, Dr. Azad Mozammel Azad Khan, Dr. Samsul Arifin, Dr. from East to West, Ahmed Wasif Reza. And then we are, as I said, not most of our existing students, they help us, or our alumni, they help us this support network. But some of the students here, as you can see, they help a lot quite directly. And as you can see their name. And then we also have other support networks, potential support networks. But here also Dr. Qazi Shahnaz Repon, who was at Khulna University in the past, was a very good support network for us. So we made use of this support network. And then we cross-check, and then we make sure that the students are good and a good fit and have not exaggerating the fact. So what I am suggesting to our to those potential students, that try to build a support network or try to find someone kind of who is who could really promote you to the best level possible, and that's your job. If you have a strong support network, or if you have a strong support for yourself, you will be getting in. So we have a strong networks, a strong students, good performance. Of course, as I was saying, we also made use of our students. So I usually, even when I need to interview someone or when I find someone, I even most of the time do not interview the potential students. I ask my students to talk to them. And maybe sometimes when I interview, I do not look, a lot of different other things. So what we did, we have this a strong support system over time. We build a structural community. So we say senior helps junior, alumni supports new students. Then their families become connected. Colleague, we get advice from colleague. We get mutual help, and that happens across generations. So this strong lab, I'm kind of proud of my lab, my students at the lab. I'm not saying I am the best in the world, but we are kind of doing good. This lab is not built by one person. It is inherited across generations, and all my students, my colleagues involved, including my wife, Dr. Bonani Roy, everyone is, behind it. They are supporting behind directly. Even Dr. Bonani has been working not only at home, actually, and in office in this research, funding those different multi-million dollar grants. So she has been also a co-PI and have been working all those. She has a lab. She is also a director of the IC lab, and we do similar kind of research. Yeah. So what we do, we look for the students' writing quality, right? Look for their if we look for whether they are generic templates, whether they really studied my research area. Like I was talking about different cluster of the research area. That is also kind of focusing. If somebody is emailing me, this is kind of a secret, right? They have to really know who are the students working this, where do they publish. Like I didn't even mention any of the places where we publish. We publish a lot of those top places, all those, right? And what is the cluster, what kind of paper I published in bug localization the last year. So I want to see those kind of things, who is emailing me. If somebody says, oh, I read this or this paper and this paper looks interesting, I never read that email. But I know that you followed a lot of guidelines to write that email. Okay, just to give you an idea. Publication quality is good if you have good publication, but doesn't really always matter. But what matters is if you have something, try to have good result, not something people have some confusion about the publication venue, right? Grades may be matter, but not all the time. English proficiency is good to have the minimum one. If you have better, is good. But if you do not, it might be good if you have a good support network and if you show that okay, you have talent to do graduate research. And for Canada, GRE is not that required. Some universities in USA, they will need GRE, of course. And interview process, as I was saying, if I do interview, I do not really ask them technical questions. I ask more on how good they are, how approachable they are, their communication, their maturity, or what I might ask them some like open-ended questions, whether they can what they respond. So yes, the practice is here. Like we have, you don't need to be graduated before you apply. So you can graduate, you can apply when you are in your fourth year. IELTS is a good, but it's not that it is the only way to secure funding. You do not have to be like in our lab. We have students across all those different universities, as I was saying, from Brac, right? From KUET, CUET, from IUT, from JUST, from Haji Danest, from Daffodil. So we hire students from different universities. And because we know that, the talents could be from anywhere. And we believe in that fact. So you do not need to be from a top university to go to a top rank university. And also, you do not need to think of, okay, if I, go to a top rank, only then I can do better. Even you can come to a, normal ranking university to US, Canada, or any other place. And if you have a good, research area, if you have a good supervisor, you can do better. Okay. So of course, recommendation letters are important. And that's what I was saying. You have to have your own support network as well. I have my support network. You have to have your own support network as a student. You have to work with people. You have to try. You have to convince them, right? And maybe, as I was saying, when we apply, maybe choose some university and really do some homework before you apply. What is this area, what they've been doing, and so that the professor gets some time to read your email, get interest. You do not need to know your exact PhD thesis topic, but if you can show the interest, if you can show some homework, that will get you in. And if you have industry background, that's a plus. That is not bad. So if you have 10 years of industry background, oh, what will happen? No, we might consider that better, or that professors might consider that better. Okay, so what happens? We We have a support network. We have a family-like environment. We have a strong talent because of that. We follow, and it is kind of inherent in our lab that we do care. We care about students without conditions. And I would really request all the professors who are listening to this, for example. I know that everybody of you are doing it, but we have a lot of those also, issues with supervisor-student relationships around the world, right? So if we have care without conditions, if you can trust each other, right? If you know that, okay, my supervisor will not be mad even if I tell what happened, I got screwed up with my data, then you will never do something wrong with your data, for example. If you are in trouble, the supervisor should help. Respect is another thing, right? Respecting each other, like my students. I'm always strict with them, but I also respect for everything, for their research, for their family, for their any issues. And my students most of them are university faculty members back home in Bangladesh. I treat with them as students, but at the same time, I treat with them as university professors as well. So it's a freedom is another thing. I have freedom for my students, and we always try to empower students to lead senior students to junior, and someone is expert, then help the other one, even if they are the senior. And we have this community, because we believe in no one can stand alone. And in our lab, we always think that the leadership is a service role, not a status. So like me, I also sit in the lab often, and students like it. I mean, they like it sometimes, they sometimes don't like it, okay? But I'm just saying, it's a kind of how you treat students, right? So focus. The final message, what I'm trying to say is focus on the students, support them. Support them whatever ways you could, academic, non-academic. It's not that you do not need to, know their personal problems. I think you should need to know. You do not need to invade them, but you need to support them if somebody is in trouble, whatever ways it is. And you need to always think of how to empower the students, the ways, different ways. Can I really empower my students? Which you always do. Help them grow as researchers and as people. Okay, so if we help them grow as a researcher, we focus on them, and as people, I think all the impact I have been talking about, a lot of publications, high quality publications, a lot of awards, jobs in Meta, jobs in Amazon, in faculty positions, Chancellor, Governor General, Chancellor Awards, everything will follow. Like in our lab, most students, or all students until now, as I know, they get jobs right after they graduate or before they graduate. So this is kind of the trend in our lab. And I believe that most universities, if you are doing good, it is kind of the trend. So final message, the concluding remark in my today's talk, and what I was requested, invited for this, to show Bangladeshi talents and how do we do the pipeline, is that my conclusion is that there are many Bangladeshi students who excel in STEM, and they show strong analytical skills. I have no doubt about it, and I showed it in my talk. And in Bangladesh, there is a large population, large number of students. If they get, they are motivated to contribute to higher studies, to do excellent research. They are ready to come to North America. They're ready to come to, globally to other universities. And this potential should be, we should make best use of this, talented Bangladeshi graduates. And we have shown this, the consistent achievements, not only in our lab. I know in a lot of places, Bangladeshi students have been doing globally with different research settings, right? If they have good resources, if they're in a good lab, and if they have good mentorship, they have high potential for innovation. I strongly recommend the professors to consider Bangladeshi students in their graduate research hiring. And I also strongly recommend doing advanced studies and international collaboration with Bangladeshi universities and Bangladeshi professors. Of course, some of the resources in this talk, we took it from this website, some are from these papers, some of it generated from AI, like LLM. Thanks to all the students, like even for this talk, all the students in my lab, they kind of contributed making the slides. And these two students actually further work them, refine them, fine-tune them, add a lot more images, all the different things. So thanks. So this talk is not my talk. This talk was prepared by the students. I am just presenting here in front of you, just talking to you. So thanks to all my students, and thank you all. Dhanyavad. Thank you, everyone. I am up for questions. Thanks, Andy and Sridhar.
All right, thank you very much, Chanchal. That was fantastic. We have about time for 10 minutes of questions, and I've got a bunch from the Q&A thing. We've got a few about the content of your science. Philippe Vincent asks, don't you think what we need is semantic proof of a program? What AI does not provide yet? And AI does not provide this yet.
Yeah, so that's like
early on in your talk.
I know. Yeah, so we of course need. I was saying that this AI is producing code fragment or generating clones, or like we are doing the translation. So these things are not easy to judge. So in our validation, when we are looking at the semantic proof, we kind of did it. We also looked at functionality testing. So we looked at the code fragment, we looked at their input output, and then we run them dynamically. So we did that. And some of the cases, as I said, because we did it on the randomly, we didn't do for all the things. It's not possible. But we found out quite good performance with LLM. But in the same time, as we were also looking at the code generation capability with more fine-grained, more manual analysis, not only the dynamic analysis or tool-based analysis. We looked at, and for most cases, when you really give a good prompt, it gives kind of good outcome. Although it has hallucination problems, and we are also exploring trust issues, risks. So we need it, yes, we need further studies, and we are exploring.
All right, cool, thank you. Next question from Guru Bandari. Also early on in your talk, how can we address the challenges that arise in automated program patching when using LLM-generated patches, given that the patches are often imperfect and still require manual review before they can safely be applied?
Yeah, so that's what we were saying. The LLM is not there yet for issue resolution. Right now, we looked at a lot of data, what developers are doing. The developers are still not successful. Developers are right now just doing idea generation, getting some idea. Okay, I have this issue. Can I get some idea what LLM says? Can I really explain this? Whether LLM has some, like we Google it, right? With some information. So they are still now kind of doing that way. Still, for those making use of LLM, you need very good context. And because this issue resolution, when you look at the bug, you don't have enough good context in the bug report. And that's what I was talking about, like my students, like Samima Mukta there, she's like looking at multimedia kind of thing. And issue is even further, right? Issue has more all those things and doesn't have right context. If you don't have right context on the issue, then issue tracking system cannot really make the best use of LLM. So it's still not there yet. And there are a lot of research potential for this. Thank you for the question. We have been actually exploring those things.
All right, we're going to switch over a little bit to the other half of your talk. What do you recommend as a graduate student for connecting with others in the community? And this person says they're in a different lab at Saskatchewan, but it's hard to feel like I have a community as a graduate student. It's been a good experience, but I often feel like I'm working on my own most of the time.
Yeah, so this culture should change. So just feeling like working on your own, I never recommend it. And that's why like we need to, sometimes, as I said, we need to be like a family. We need to build, not only even work. If your work is not relevant to your lab members, why not you share a birthday party? Why not you have some celebrations? Somebody is defending the thesis. Why not there is a celebration and you attend there and you talk? Then you get a scope to talking about your research, and then that way you can kind of get linked. You never know how can you get an idea, and by doing it, by being friends, and by in the same time being professional, you can build your network. You can talk about your work. So it's highly recommended, and that's what we always follow. In my last 15 years, 16 years at the University of Saskatchewan as a professor, I have been doing it every day.
Great, thank you.
Make the students connect to each other. That's one of my primary jobs. And if there are conflicts, I know I run a large lab. If there are conflicts, we try to, as soon as it comes to our mind, we try to resolve it and make them friends again. And we try, okay, for a greater sake, you have to be, kind of that they understand, and they also know they're working in a lab. Each one of them is a support network for each other. Yeah. So that's the philosophy they follow.
That's great. I want to interject one of my own questions before going back to the Q&A. In one of your slides, it sounded like you said you arranged the marriages of several of your graduate students. Like
not
arranged,
several.
like
We
their
arranged
parents
marriage for
arranged,
one.
or
Oh, so that's a miswriting. Then we married for one student last year because their parents, they are new students and their parents are not. None of their parents are here. So in our lab, we become kind of a father, mother kind of thing, and my wife and our lab students become their relatives. And then we celebrated that marriage, and it was a wonderful marriage.
celebrated the marriage. Okay, cool. So they
And
already have
the other comment was we arranged the marriage. Actually, we arranged and celebrated. Actually, we arranged the marriage too.
What?
So we are the kind of all the lab students were involved in arranging the marriage. Yes,
Am I arranging? You mean like you made the party happen?
We made the party happen.
Got it.
Yes.
Okay, yeah. Sorry. So anyway.
We made the party happen. Yes.
Good. Okay,
we
cool.
worked together as a family, both family. Yes.
That's pretty awesome.
And I was saying the other message is that we had 9 couples that have graduated or have been graduating right now, studying right now in our lab. So we support also couples. So that's our first priority. If somebody is coming in our lab and we know that they need their spouse to be in the program and they are eligible, we try to do that first. If not with me, with colleagues, but that's and in my kind of career, we had 9 of those couples. They have graduated or have been studying currently in our lab. Yes. So that's
cool.
So that's kind of thing we follow. I mean, I know that talent is problem, but in the same time, we understand the family. We understand that we have a need for that family, and they both are kind of eligible. So we try to give them the highest priority.
That's really cool. I want to give you one last question. You rely heavily on your network of people that you know at the university around software engineering in Bangladesh. How do you ensure that you are able to spot talent that's coming from outside that network in order to recruit them as well?
Oh, I did as well. We also hired students outside of the network. We not only hire from Bangladesh, first of all. We have students. One of my best students from Canada. He's at Amazon right now. And a lot of other students from Iran. So we have different students from different countries. But again, I have some other strategies that I followed. Right? How do I look? How they communicate? What happens? Whether they are really understood my area? Did they really able to summarize it properly? I follow all the other things that I was describing. So we also do routinely other students, and because this talk is on Bangladeshi students, I only focus on Bangladeshi students and only on the current students. So we have a lot of those, like as I said, 75%, over 75% of our students are from Bangladesh, of course, and not all of them are from that support network, right? So there are also some outside of the support network. So it's not that they have to have that support network. They have to have, kind of their excellence, like, looking at, if somebody is emailing me, they have to look at what I'm doing, what is my recent work, that area, who have published, how many papers, where, kind of those kind of things.
Great. Sridhar, you wanted to say something.
Yeah, just one quick, thanks, Chanchal, for this excellent talk. One quick thing, like, how do you support the transition? Let's say, when Bangladeshi student joins your lab, right? The expectation or the background context would be very different from their thing to your lab. So, do you have some sort of a boot camp, or how does it work in terms of that transition?
So we do often gathering, and even like Dr. Bonaniro, we had a couple of years ago, we had Folk Fest. Folk Fest means you have this cultural gathering for different countries. So Canada has those kind of things. She even does, our lab students from different countries, they even did a performance and showing how, different countries, students, have happens, what happens. And then we try to learn from these odds. So there are different odds. So we try to teach them these odds are normal and you have to cope with the odds. we so diversity, and this is always we try to cope with it by mixing them up. So it's not only that the Bangladeshi students gather, all the students of the lab, they have to gather and they have to be each other, they have to collaborate, they have to work, they have to join this any social gatherings. So we do it, and we know all the words, and I think we overcome those words very well. Yes. Yeah.
Great. Thank you very much.
Thank
We're
you.
out of time. So I just want to say thank you very much to Professor Roy for your wonderful talk. And thank you to the audience for coming today. This talk is being recorded and will be available on YouTube in a few days or so, maybe like next week sometime. And then anybody who has asked for a certificate of attendance in the chat, we're going to process that again in a few days. We're going to match that up with your email addresses from the registration in Zoom and send you out that certificate next week sometime. But thank you again for coming, and I hope you have a good rest of your morning, afternoon, or evening, or nighttime, wherever you happen to be.
Okay, thank you. Thank you, Dr. Andy Bagel and Dr. Sridhar. I mean, it was a pleasure, and I'm really honored. And thank you all for being in this talk. It was good to talk to you, all of you. And maybe I couldn't talk, directly, but to talk to you about our research, about our students, and I'm proud of my Bangladeshi talents. You guys have a lot of potential to do it. Let's do it. Let's get the ball rolling. Thank you.